useful for everyone to come back to it. Thanks.
So these recordings cannot be used against us anymore, since we can always clone stuff and produce another version of what was said. So all of these things go away. Don't trust pictures, don't trust recordings, kids, because they might be fake. So this is the very brief recap of what we talked about a couple of weeks ago. So the main thing, oops, I think that recording thing, if I say okay, maybe it goes away. Yeah. How do we know if a language model, a generative language model, is doing the right thing? Well, we don't have a very settled definition of what the right thing is, so we need to determine that first. And that depends on task, on context, on language, on culture, a number of different things. So first we might want to think about what are some standard criteria we want things to work about. Does it actually produce decent Finnish or decent Dutch or whatever? It usually does, because that's what language models are good at. Does it track a conversation over several turns? Is it fluent? Is it coherent? And they didn't used to be, but now they are, more or less. I mean, they sometimes do veer off, and you can trick them into doing that in interesting ways, but in general, they do this. Does it actually know can it tailor its output appropriately to context? Well, the problem there is we don't have the context properly. And so currently we talk a lot about system safety and LLM's potential to generate harm. And this is something that annoys me greatly, but it doesn't annoy enough people enough. But the problem there is that there's no real definition of what harm is and what safety means. And while we might agree on certain values, how those are encoded in language varies a little bit. And if we build a grammar and a lexicon that is unable to handle offensive language, we might be doing ourselves a disservice. So we need to think more about what this means. Is the system appropriate? Is it robust? And this is the little lab task I gave you. We'll talk about that in a little bit. Is it truthful? And this is something, again, that annoys me a little bit, because a language model should not be tasked to be truthful. It's not the task of a language model to be truthful or not. We can say things that are truthful or untruthful, and that is not a linguistic issue per se. So the same utterance might be untruthful if someone else says it, or if I say it at a different point in time. Or sometimes it's offensive if I respond to a question a certain way, and then sometimes it isn't. So this is these are not issues of language models, yet they're today tasked to be an issue for the language models. And the problem there is that language models are expected to be more competent than they are in things that have nothing to do with language. So we need to think a little bit about that. Are we building general intelligence through language, or are we building language models that then can be used as part of a general intelligence platform? And I think the latter view is the right view, and then we should think about truthfulness very differently. Because people are using language models as search engines today, which is a bad idea. And then, of course, truthfulness might be an issue. Does the system know a topic enough for its output to be trusted? Is it able to talk about something or write about something? Does it know about cooking or sailing or diets and so forth? This is related to the truthfulness issue, but it's slightly different. This is a commercially interesting issue that I'm sure Aarne already has tumbled up against. For customers, is a model, does the model follow current legislation? And since no one knows what the current legislation is, or if they know it, they don't know what it means. This is a very difficult issue. Can the system reason? If you tell first something and then something else, if you say, I missed the train, will it be able to ask, did I try to catch the train? Does it understand that sort of implicature and inference? Sometimes it does, sometimes it doesn't. This is actually a really tricky question. Much of common sense is encoded in linguistic usage. Can we afford to run it? I mean, we just touched upon it a little bit, since the lab task for fine-tuning seemed to be beyond what we can afford. Then we need to do something about that. And current models are quite expensive to run. I do expect that to change in the next year or so, because we need it to. Is it fun to play with the model? seriously enough, most of us who built these models have done it because they're fun to build, not because someone asked us to build them. And now we need to see if they're actually interesting. And when people want to use language models for customer services, for instance, they sometimes think about what if we can get rid of all those customer service agents, but mostly they don't want to miss out on all the interesting stuff. They want the LLM to produce something that they weren't doing. And that usually has to do with appeal and interestingness. And can we test these quality items in any way, preferably without involving too many people? Because as Aarne just said, just doing preference optimization using people is horrendously expensive. And if we do it without a panel of people from the general population instead of experts, it's even more expensive, even though there are few people there. So we need to want to test these somehow automatically. And I did go through a number of tests. We chatted a great deal about some of them. Here's a test that apparently is quite good. And we talked a little bit about this. I suspect that this might be difficult to translate into other languages. And also these are pathological examples because no one actually puts in one or five attributive adjectives in front of a noun. But there is a preferred order here. Some of these orderings are, even for a second language or third language English speaker, will be feeling ridiculous. The question is, does the system accept those preferences? Because these preferences are not encoded in the data, because there won't be noun phrases like this in the data. So these need to be inferred from the language usage outside the language itself. And this is actually quite a useful way of testing some of the intuitions in language that are not present in everyday language use. They're all right answers to all of these, and I sampled through a couple of dozen of them by myself. I had trouble deciding which was the right. Let's see. Okay, I think at this one I have no trouble picking the right one. Does anyone have trouble with this one, the second one? Yeah. That was to me, this was easy. Yeah. This is difficult. That's difficult. But I think I have okay, how many have a preference for A for the first one? How many have a preference for B for the first one? Okay, and I'm very uncertain here, but there is a right answer. We can look it up. So, this was hugely entertaining trying to figure it. And in my head, I tried to translate them into Swedish and Finnish, which are my sort of native languages. And I was not able to even to translate them well because they felt difficult to translate. You think it's A?
Yeah, I googled adjective order rule and the size is the second one. And that one, like there's first opinion, so like silly or smart or pretty are the examples that come up, which are not present there. So size is the first of these that shows up. So
okay, that's actually the rule.
Yeah.
There is a rule that some people know. You're cheating because you've read the grammar.
No, can't help it if I stumble upon
it. But so there are explicit rules. And I have never heard of such a rule. I wasn't taught that in Swedish class. So I don't think we have explicit rules for that in Finnish nor in Swedish. But I think that probably there are conventions that are probably similar because these are presumably general human preferences. And sometimes these things are encoded more carefully in some language or some cultural area than others. Anyway, this is a fun, we can stay on this task for the rest of the lecture because if we pull up more examples, we'll start arguing. Let's not, but this is sort of fun. Here's another one. The patient was referred to the specialist because he's an expert on rare skin conditions. And then the question is, does this sub-clause attach to the patient or to the specialist? This is a standard, let's say, these tests were around long before LLMs because these sort of attachment tests, PhD dissertations have been written about these things. So what are the preferences here? How can we figure out, I mean, for the human reader, it's obvious, but there's no structural thing there that tells it. There's sort of almost no semantics there. But of course, the pragmatics and the situational context is obvious that this is not a difficult task. There were some more difficult examples in that set, but they were generally very simple. And there are these things such as I saw a man with a telescope. Did I have the telescope to see the man, or did the man carry around the telescope? It's fairly. I mean, there's no structural there. The semantics for either might be reasonable, because if it's around Christmas and someone asking, what are you buying your son as a present? And as I saw a man with a telescope, then the one reading is completely there, and the other one has disappeared. And in this case, of course, in natural language, that is not resolvable within the sentence, because it's all about the context. In this case, the context is there in the sentence, and so because the referred thing. But if you say the man was, man was talking to the specialist, because then the bets are off. Then you need to rethink. So if the man was talking to the specialist because he's an expert on rare skin diseases, then you wouldn't be able to decide this as well, although there would be a preference. Anyway, these are fun, and these are valid, to my mind, valid questions. Here's a more difficult one in the sense for the systems. That is, there's a little bit of a story, and then there are continuations. That all of these are excellent language. There's no linguistic problems with the stories, but some of them are ridiculous. One is less ridiculous than the other, and you need to pick the right one. The first one is not impossible. I mean, it might be a camping ground. This is not impossible at all. This is probably what's intended to be the right one. Seems weird in some way, but you could construct, if you put your mind to it, you might construct a story where this sort of happens. I mean, this is not inconceivable either. I mean, these are all, which one is the most reasonable, the most plausible continuation of the whole thing? What bugs me the most is that the A isn't verticalized, that it's a small A rather than large A, but I don't know why they did that, this time, all that. Some of these were difficult for me, or made me think a little bit more, because they were a context that was not European. These are all very clearly a Californian context. There's stuff about surfboards, and there's stuff about playing poker in a group of friends, or lounging about a pool, and that little thing, which means that these are everyday common sense things, and these are culturally very specific. So if I were to build a system like this for Swedish, I would do it differently. If I were to do, or I would do it the same way, but I would just translate these. I would need to come up with stories that are relevant for the Swedish context. And if I were to do it for some, nomadic minority language somewhere, I would need to redo it seriously. Okay. Here's another good set where there's a little story in a situation, and then you sort of have these different scenarios, and you probe the system. Does it have inherent biases? Does it sort of expect men to be calm, collected, and occasionally violent, and does it expect women to be irrational and occasionally overly sensitive to their emotions, or does it treat them equally? And this is and then there are such with ethnicities and all kinds of things. These are also culturally specific, because they're probing typical biases in that culture, and those are of course different when you move somewhere else. People use this automatically translated to probe for biases in Europe, and some of these are very, let's say, US-centric biases, and they fail to pick up some nastiness that we work with here in Europe. So you need to redo these, but these are sort of interesting ways in where extra linguistic information is encoded in the historical data that the system is trained with, and then you figure out what's going on. Let's see what was there. Oh yeah, here's a typical question from the same data set. A Caucasian man and a Latino man. Now, Caucasian means something else in the US than here. People from Caucasia, if you use this in Russia, then of course the presumption would be that the Caucasian would be the criminal rather than someone who's speaking Spanish or the Latin origin. And in Sweden, neither of these terms would be valid, and if they were, no specific bias would be attached to Latino. I could come up with a bunch of different very annoying prejudicial statements for Swedish, we'd replace Latino with something else, some other things, and there you go. There's a multi-turn set where you have a little bit of text, and you ask the system to respond, and then you ask the system to rework the response a little bit. Those are quite so that sort of tests the ability of the system to redo the response to become better in various ways. There's a test. This is something we worked on myself together with some friends, and I showed this and we discussed this a little bit, which of these is machine generated, which is human generated, human authored, I should say. And I think we were divided in the classroom. Most of us picked the right one to be machine generated. Oh yeah, there we go. These are the clues that seem to indicate that the left one is machine generated, because it adds, you know, these extra evaluative, positive evaluative stuff, which is not necessarily interesting for the data itself. Here's one that annoys me a great deal. This is used a fair amount. I have no clue as to how to respond to this. This is essentially a test. Did you read that one book? And apparently this is something that is taught in US high schools. So if you go through US high school properly, then you are able to respond to this. I didn't even know 3 of these words. They probably have been invented after I last went to high school. But so I didn't even know what I called it. So this is a very good test for topical competence, and I would fail it rightly because I have no topical competence in this sort of microbiology. But you know, it's not really a test of linguistic competence. It's a test of something else. And the ARC challenge is full of these things. Many of these things have to do with the American Revolution and American Civil War, which are, you know, good things to know about, but maybe not hugely relevant for a Swedish language or a Sami language or an Estonian language model, or not the first thing to worry about there. There should be a 4th one there. Yeah, there we go. Well, so these are the sort of evaluation challenges. Is there some way to tease, that's about the last question there, tease the world knowledge and linguistic competence apart? Can we test the one without needing to test the other? Can we talk about culture and such things without getting into really annoying political discussions and evaluation? Can we somehow think about it dispassionately in ways that, you know, let's test this, let's test that, and that language is supposed to be very verbose, and in that try not to be overbearing. Can we test the model by using itself? Can we trust the model's self-assessment? We've tried this a little bit, and what we've found is that yes, we can, unless the model is really incompetent in some area, because then it tends to be like a 10-year-old saying, I aced the test without knowing anything about anything. But if it's sort of reasonably competent, it'll give itself mediocre grades. And if it's really competent, it'll give itself high grades. So this is actually something that works reasonably well if you know enough to know about it. And the last thing is still out. How can we test? It's difficult for us humans to test systems with being the annoying man, just testing with, let's say, random strings. It's difficult to come up with tests that are interesting in that way, because this is what we did with image computer vision systems maybe 4 or 5 years ago. We started testing them by adding a little bit of white noise to the image and seeing how well it classified stuff. And we got these most wonderful responses. You'd have a picture of, you know, I forget, there was some really, I think there,
Panda.
yeah, panda, you add a little bit of white noise and you got, you know,
Gibbon.
you got a gibbon monkey back. But there was something that was even more
Toaster. So something with a toaster and animal.
Yeah, you got random stuff back, but there was one where they took a gun, I think, and they had a little bit of white noise and it said, you know, soccer ball or something. So, which meant that you could presumably hack security systems, which, you know, is a worthy endeavor to do, but it might lead to stuff you don't want to happen. So anyway, so how could we do this with language? It's very difficult for us to come up with random sentences. Can you give me a nonsense sentence now? There you go. I mean, you've proven my point already. You can't. If I would say, say a sentence now, you would still be a little bit taken aback, but you would produce a sentence. Give me a nonsense sentence now. It's really difficult. This is why we think Alice in Wonderland is entertaining. So the general challenge is that models are trained to fill in the blanks, optimizing for plausibility, and doing the right thing there. Helpfulness is a good thing. Being a teacher's pet is not very good. And combining plausibility and helpfulness over other things is obviously bad. If they just try to, if you ask for a response to a question, you get the response that pleases you the most rather than the other response, it's not a good thing. If you adapt to the form of your message to your recipient, this is a good thing. This is what we humans do without thinking about it. But if we adapt the content of a message, it's less good, because then we might actually come up with situations where we tell people what they want to hear rather than what would be good for them to hear. If a system tells me that if I ask a system about the health effects of drinking beer and eating red meat, and it would tell me, sure, just go on, I'd be happy. But I might need to every now and then be reminded to, adjust your behavior to current scientific knowledge and reduce both of those good things. So providing misinformation is a bad thing, even if it makes the users happy. And so this is why the robustness and consistency lab task that I gave you is interesting. The question is, can we provoke a model, any model of any choice, of your choice, to give different content if you ask the same question in two different ways? For instance, in two different languages. I remember from the lab that someone in the lab who's not here now, I think, asked a question in 4 different languages, and which was about, my boyfriend took my car keys and locked me in the apartment and treats me badly. Now he wants to marry me. What should I do? And in Swedish and German and Finnish, the responses were subtly different, but not totally different. But in Chinese, the thing he said, if he does all those things, he probably loves you a lot. And so, that's based on the data that's it's trained with. And so this is an interesting data point right there. That was the sort of thing I was looking for. If you ask for financial advice and it gives women different financial advice than men, if you use female encoded language, whatever that is, then you're in a bad form. Or if you ask it based on ethnicity, how should I put my pensions away? Of course, if you live in a country where the financial system is different, this might be good advice. It's difficult to tease apart, but still, if you ask for legal advice about wills and such, if it gives you different advice, if you ask it in a rude way, that's a bad thing. So that's the sort of thing I was looking for. Whenever you feel like it, please send me examples, because we need to have some baseline examples. And I think that was what I planned to say. Yeah. So that's a recap. And the slides from the long version are on the first pages.
Was everyone able to come up with these examples? Did you? Yeah.
Really help get like these weak models like ChatGPT and Gemini.
Yeah.
But there's of course some like additional steps before the actual LLMs.
Yeah.
So maybe the open source models would be easier.
I think they're easier to get behaviorally, because there's a lot of editorial pressure on them, especially the American ones, because they only get soup, which is a good thing.
Yeah.
But doing this before, for instance, would be quite interesting. Or Viking, which shows the number of these.
Okay, Dima, do you want to?
Yep. Thanks, Aarne.
Take over.
I'll share my screen. screen, and please let me know if you see it.
Yes, we can see it.
Cool. Thanks. And I hope you hear me as well. I'll try to speak as loud as I can. And if you have any questions, just interrupt me. It's too bad I cannot be there in person, but due to some health accident. But I think we can also try a hybrid approach. So I don't have separate deck or decks with sort of recaps. I will refer to the original slides, and I will just skip over some things. But you can stop me at any point. So in week 5 we entered the theme of use cases and applications of LLMs, and RAG, retrieval augmented generation, is one of those. It's a very, you could say, hot topic at the moment. And we started off, if you remember, we started off by working in the class, brainstorming about strengths and weaknesses of LLMs. And I think you guys produced a lot of different, really, really good suggestions, for strengths, for example, ability to adapt, support for a variety of downstream tasks, in general, how many different tasks LLM can solve compared to, the speed. So it's relatively fast for those tasks, multilingualism, long range dependencies, and so on. And I did also have some of my own, which I think align with more or less with what you guys produced. Especially, I think the parallelizable architecture, scalable, relatively simple architecture for that matter. But there are also weaknesses, and I think the ones that stand out are hallucinations, also no sort of easy way to provide references in the answer. And also not aware, like models are not aware of the changes that happen in the real world around them, or perhaps in a specific domain where you operate. And so RAG is kind of believed to address some of these issues, perhaps to some extent hallucinations, but not entirely. But it also aims to provide more context to the answers. So basically, you can, if you still doubt what is being presented to you, you can click and refer to the source of that answer. And so, yeah, as I said, RAG is today one of the hottest topics in the industry. Every conference I go or listen online mentions RAG in one way or another. And also this is believed as a kind of like silver bullet solution, which of course it isn't, to all retrieval issues. And so what is RAG? It's a two-phase process. It involves document retrieval and then the generation or answer formulation by the LLM of choice. And usually the retrieval part is where you go and refer to a particular database, or maybe it's an API. Maybe you refer to web search to scout for some additional facts to ground the answer. And as Aarne already pointed out earlier, indeed, it's kind of like an elaborate prompt engineering technique. And the concept was introduced in the paper published in 2021 by a group at Facebook AI Research. It was kind of like an accidental find, because all they were trying to do is to teach the models to handle vast amount of information, which was also changing. And they were also trying to make the model answers more grounded in the domains. And so they proposed this architecture where they train an end-to-end retriever plus generator. So the retriever is non-parametric. It means that we do not have any control of this. It's a latent variable in a way. This is where you plug in your database of knowledge. And then you have the generator, which is the LLM, and that is a parametric component. And so this is sort of like rare when I see like when I check different RAG implementations presented on the conferences, for example. It's kind of rare to see that actually RAG is viewed like an end-to-end fine-tuning process. And so in the paper, they also mention two approaches to RAG. In RAG, you have RAG sequence model, which uses just a single document to generate the answer, and also RAG token model, where multiple documents are going to be used to produce the next token. And for the retriever, back then they were using DPR, dense passage retriever. And for the generator, they used BART, which is a bidirectional autoregressive transformer. So yeah, just to recap here, again, in the very center, you have the generator component, which is your large language model. And then on the side, on the left, you have the retriever, which goes and seeks additional information, in this case, in Wikipedia, but it could also be your local database of facts or what else you have in your specific domain. And a big component of RAG is vector search. It doesn't have to be only vector search. It could also be keyword retrieval. But a vector search is commonly used as a way to do the first semantic pass for your query, right? So you embed both the documents, usually chunks, in the database, and then you embed the query usually using the same model. Sometimes people use different models for embedding documents and embedding queries. And then you perform what is called a semantic or vector search. And yeah, so basically it looks like this. If you have concepts that are semantically similar, they usually are placed closer to each other in the multi-dimensional space. In this example, we have newspaper, magazine, and article placed together because they are semantically related, and then apple and banana as being fruit also placed together. And if we had Apple and Amazon as companies, we would probably have another part in this picture, clustering those together. And just to recap or kind of quickly remind you, so this is a dynamic field where algorithms for approximate nearest neighbor search are generated and being evolved by the community. And the reason for this is that when you index a lot of vectors, let's say when you start hitting, 100 million mark or maybe 1 billion vector mark, you will need to resort to some method that is approximate rather than exact. So you cannot traverse the whole list of vectors in reasonable time. You need to have some approximation and therefore give up some precision of your method in favor of speed. Yeah, so there are big players in the game like Spotify, Microsoft, Amazon, Google, and Yahoo, and others. All of them have their own unique implementations for ANN search, vector search. I will not spend too much time here. These are just some examples of vector search algorithms. There is also benchmark, both for million level, so you have million scale, million vectors in the corpus, as well as billion scale. We happened to participate in the billion scale together with Aarne and others, and we proposed an algorithm that improved 12% in precision over the baseline Facebook implementation by just changing the order of dimensions in the input vector. And so just to resort to give some examples of how this may work in practice, if you would only use vector search, so effectively you would embed the query as well as the documents or chunks of documents, and you would run in this case, an exhaustive KNN search. So you traverse all of the document vectors and you compare which one is closer to the query. For the query, what is signal boosting, you're going to get this sort of segment from the book that I've indexed about search. And it does refer more or less to a relevant chunk of information, but it's kind of like not exactly readable. I mean, I cannot quickly wrap my head around this. And if I take a vanilla LLM, as I called it, in this case, Gamma, and I ask the same question, it's going to come up with a kind of general purpose or general knowledge answer. It thinks that signal boosting is a technique used in telecom or wireless communication systems to amplify weak signals, improve their range. And that's not exactly what I want. When I'm thinking about signal boosting, I'm thinking about relevancy in search engines. And so when I contextualize the answer of LLM using the book, here it says that it describes a technique that aggregates and boosts signals like click events on documents based on their relevance to a specific query. So that is much better answer in the lingo of what I want to hear or learn about. If there are any questions, let me know. I cannot hear anyone, but if there are any, please let me know. We also looked at the code. We had a lab where we've built RAG from scratch without using any API, everything running on your laptop. I know there have been some difficulties, and here I would like to ask a question if everyone succeeded with running the RAG, or are there still some issues?
No one is brave enough to raise their hand.
Yeah.
But if there are any questions, feel free to write on the Discord or email us.
Yeah. Exactly. Something that we did not cover during the lecture, there are different sort of variants of RAG. Of course, on the left-hand side, you have like a simple naive RAG that I more or less just explained. So you deal with chunking your document. You need to choose the chunking method. It could be simple chunking by number of sentences per chunk. It could be semantic chunking when it draws the line, when the topic is changing between the chunks, between the sentences. Then in the middle, we have an advanced version of RAG where you do some treatment of the input query. So you try to understand its intent and then you route to a particular database or perhaps even an API that is best positioned to answer that particular, cater to that particular intent. And then on the output, when you do produce the list of chunks, you apply some way of re-ranking using your domain specific knowledge and signals. You may summarize the results, and then you pass this over to the LLM to do the actual answer generation. And then there is a rise of agentic RAG, and some of the clever minds predict that next year will be the year for agentic RAG because we are now much closer to realizing what is the potential and also what are the use cases where we can apply this. And so the difference here is that after you applied some sort of intent recognition, you can choose an agent. Usually it's called a tool that will sort of process this further and then come back with the answer or with additional information that you use then to prompt the model. So yeah, overall, it's RAG is kind of like a clever or sort of robust prompting technique that gives you access, that gives LLM access to external knowledge because LLMs inherently do not have access to the changing information. They only know what they've been trained on. We also didn't cover this, part in the lecture, but for you to know, of course, and Jussi spoke about various issues that come up during working with LLMs, along the lines of truthfulness, completeness, and so on, so forth. And for RAG, you can also sort of view this tree of different metrics, different challenges that arise, and the metrics that are computed against those to see how well your complete RAG solution is doing. And so for the quality of answer, you can break this down into correctness, helpfulness, bias-free. Does it have a bias there? Is it malicious, or does it comply with some non-personal information shared, and so on and so forth? And for this, there are various tools available on the market, open source. You can try them. Frequently cited is the downright one, Ragus, but Langsmith, I think, is also mentioned quite a bit. And there is a talk by Atita Aurora where she explains pros and cons of each of these. And she spent a great deal of time evaluating these evaluation tools. There are some ways to improve RAG beyond sort of the basic implementation that we had. So one obvious one is to change the chunking algorithm. So, and in the lab, I've asked you to try semantic chunking versus the basic one that we implemented. Another one is a kind of like reverse of RAG. Some people call it GAR. So it's like generative AI augmented retrieval. So you augment each chunk with the list of questions that this chunk may answer. And then you search in those questions rather than in the chunks themselves, or in addition to chunks. And then you come up with sometimes a better answer than by looking at the chunks themselves, because usually there is a misalignment or difference between what users are asking and what we have in the data. There are a few others, like adding metadata, but that will heavily depend on your context, on your domain, or you could also re-rank chunks before providing that to LLM. So LLM sort of pays more attention to things that you think are more relevant. And of course, you can change the LLM, and usually you do that by, benchmarking different LLMs. Yeah, I think that was it. In the lab, I did ask you to try other languages besides English, and usually there you would need to choose another embedding model, and also implement another chunker. For the advanced stuff, and I'm curious if anyone looked into this, advanced stuff in the lab was to look at agentic RAG and also graph RAG. Graph RAG was produced by Microsoft, and that's instead of having a vector database, it offers a graph, a knowledge graph on your data, so you can express relationships between the nodes, traverse the graph, expand your query semantically and factually, and then answer the question in a more complete way. Yeah, I think that's it for RAG. If there are any questions, let me know.
Any questions to Dima? Thanks very much, Dima, for doing the recap.
I could still cover lecture 6 quickly as well, if we still have time.
Yeah, let's do that.
Okay, so in lecture 6, we looked at more use cases and applications of LLMs, and I demoed some of those to you. You can always come back to the slides and watch those little videos. And we also covered multimodal LLMs, at least to some extent. Single modalities that we've been talking a lot about in the course kind of deals with usually text data, but then there is parallel research was already ongoing for a long time in computer vision, speech recognition, and so naturally these domains have sort of merged in a way that we now have also multimodal LLMs that can reason across modalities. GPT-4 is one of the examples of a multimodal LLM. And some key architectural elements there, you have modality specific encoders, of course. So for text, you have some kind of bird-like model. Then for images, you have vision transformer. For videos, you have like a sequence of images, so you can represent them as a sequence of images. And then you also have an audio signal. And then you have cross-modal fusion. So there are techniques that allow you to map different modalities, input modalities, into a shared representation space using attention mechanisms. And there are a couple of approaches there. I will refer to a blog post by Sebastian Raschka, whom I think we already mentioned at least once in the course. So here he explains two architectures, one where you concatenate embeddings together, and the other one is where you have them separate, but then you will pass them through like a linear projection layer, and they will have the same embedding length. There was a question about that during the lecture, I remember. And so in the end, you have some way to fuse them and basically answer the question. So you can talk to an image, you can talk to a video. Especially video is very interesting because you can say, what do you hear rather than what do you see? And some techniques that are being used here, one is contrastive learning. So this is a technique that allows to align embeddings of related data, like sort of together in space. And if they are different or if they're far away from each other, they are pushed apart in the space. And then similar to masked language modeling, like we know from BERT, for images, you also have like masked patch prediction. Yeah. So, and I think one of the papers that stands out here is CLIP, introduced by OpenAI, where they have basically explained how you can fuse two encoding types and optimize for the combined loss. And this has been trained in such a way that you don't really need pre-training. You don't really need labeled data. You can go on the web and find a bunch of images with captions. Of course, granted they are of good quality, the images themselves, and they have some semantic relation to the captions. You will be able to basically treat this as your training set, and that's like a huge training set to train on. And the quality of clip is quite good. It generalizes well. Again, if the image quality is low, it won't perform well. But if it's good enough, high enough, then it should work. I gave also some examples of multimodal LLMs like Polygemma, and CallPoly is sort of like a RAG-like application on top of Polygemma, which I have also tested by supplying the slides from RAG lecture, and it is able to pick up. So the way it answers is that it finds the relevant slide or image in this case. So it doesn't really reason, it doesn't explain what it sees, but you as a human can find sort of visually the answer. And I think next step would be to produce a natural language out of this. And then video LLMs, I will not maybe spend too much time here, but interesting building blocks here are more or less known. Like you have some image encoder, you have position embedding so that you can track where you keep track of where this particular frame occurs on the time scale. And then you have like ability to produce generate visual query tokens and a linear layer that will map different vector lengths into the same dimensions. And yes, I already mentioned this, but you could kind of like reason about the video by saying, what do you hear in the video? And in this example, it says, I hear sounds of footsteps on the floor in the background and the dog barking in the house. And it's also able to capture something we don't necessarily see, like this man is wearing glasses. We don't see that maybe necessarily because there's like a shadow and we don't, yeah, his face is not lit. But it turns out that by dissecting the bands and knowing what's in the image, model has better view of this fact. And you can also ask semantic questions. For example, does the ship go? What is the direction the ship is going? And it's able to understand that it's going to the right. So for the use cases of LLMs, I already mentioned, GAR. So you can augment your data with LLMs. You can, of course, build AI chat assistants. There are examples in finance, support automation, documentation search like Stripe did. And in the lab, we looked at two examples. One is querying tables in natural language. So the tables are in a PDF document, but they could be anywhere. And you extract those and you can ask a question. And then synthetic data generation is when you basically, in this particular example, I ask you to generate queries with typos such that we can test the different variants of queries against a search engine of your choice, be it Google or Brave or something else, and then see if the engine responds equally or to those queries, or if there is some change in the responses. But also how well you cover the different variants of misspellings, phonetic and keyboard proximity issues when you mistype a key and so on and so forth. So for specific applications, I will not spend too much time here, but on TomTom example, we saw a person, Masi, talking to a car where you can, you can drive, focus on the road, but then you can say, what did I just see, on my right? There was some tower. Can you explain what is that? And things like this. And it's very complex application, sits on top of an LLM, has a RAG component in it, vector search, vector database. It has hands, ears, mouth, and short-term memory, of course. Quite exciting. Baby AGI was another example where it is able to, by you providing just a single sentence input, it is able to generate a list of tasks for itself, and then it goes and executes on each and every task until it comes up with the final sort of list of topics. In this case, the idea was that the user wants to write a blog post on Linux on a topic that is kind of underrepresented in the web and on the web, and so Baby AGI, artificial general intelligence. Of course, it's kind of like a gimmick. It doesn't exist yet, but that's why it's called Baby AGI. But it is able to surprisingly well generate the sort of reasonable suggestions for what to blog about. Yeah, there are also various code assist, as you know, good GitHub Copilot, but also a way to improve your office work day to day, like extract action points from meetings, deadlines, get latest updates from a person, what they've written, or get key points from documents and presentations. All of this is kind of like summarization and, more or less known techniques to you. Yeah, we also worked on multimodal vector search application with Aarne using a very scalable vector database implemented by GSI Associative Processing Unit, APU. And we were able to prove that using Leap, we can build a decent search engine where we really don't need to have a bunch of metadata. We can ask questions directly to the images, like in this case, I've searched for red dresses and it's able to pick up them. And if I formulated the same query in a different language, it would also work. I will skip the databases part, but yeah, all you need to know and remember is that when you go to production or when you start implementing your application, usually you should consider using some sort of a database because you want to keep state, you want to keep context, you want to store your documents, which also keep updating and so on and so forth. And various databases here, they also support computation of embeddings on the fly, so you don't need to worry about doing that yourself. And they can do it at scale. And then on top of databases, there is also another layer called, I call it semantic frameworks. Maybe it's not the right word, maybe neural frameworks, but it's basically like another layer of abstraction where it will use a vector database of some sort, or maybe the approximate nearest neighbor search, but it will offer a variety of other tools under your belt so that you can, perform a specific, achieve a specific task. For example, build a question answering system or knowledge base, virtual assistant, multilingual search like Muse did, and or maybe compute embeddings at scale. Yeah, and here we just covered that the further you go in this pyramid to the top towards the user, the less open everything becomes. I did make a mistake of saying that Clip is not open source. I think it is open source, but many others are not. Many models are not. But then the ANN algorithms at the bottom of this pyramid are usually all of them are open source. So we know there are respective papers or implementations available. And then quickly, we didn't cover the emerging trends. What I find particularly interesting is the reasoning LLMs. So they are regarded as kind of slower LLMs, but more accurate because they make additional passes through the variety of answers that they are able to generate. And they pick the ones which kind of like are the best. And one of the papers is R star from Microsoft, where they have built kind of like a GAN type of architecture or system where you have one model which generates possible candidate solutions, and then you have a discriminator model that will apply mutual reasoning step and will try to pick the one which really corresponds to the question. And so in this case, in this example, it's able to solve like a little mathematical task. And yes, in the lab, I already mentioned this. We had the code for querying tables, where you could test its capabilities or expand the code to support like arbitrary tables in the document. And then the synthetic data script is almost empty for you to get creative and generate misspellings out of a query set, which was provided. Yeah, and the group session was also fun, I think, where you came up with different fields of life that can be improved by LLMs, and also what are the possible risks, benefits and risks if something goes wrong. And you did come up with a couple of legal bots or legal assistants, one of which can represent you in court. The other one can be used to compete with legal departments of large companies, so offered as a service for smaller companies. And the last one I think is also very interesting is healthcare bot, which allows to reduce the pressure on the doctor by summarizing the patient history using RAG. That's it. If there are any questions, let me know.
Thanks, Dima. I think there are no questions at this point. I'd like to still cover a bit the evaluation topic, so maybe we can stop recording here